For today's lesson, we want to prove that this linear differential equation is equivalent to this bad boy. So let's dive in. Our solution. The first part we need to understand is the nonlinear first order differential equation is in this form. It is in this form. It is in this form. And now, the way you go about solving this, you have to identify your main function. Our main function here is y, because it's dy dx. Our main function is y. It's even here, it shows your main function is y. So, in our solution, we are going to have y. Now, we have to find an integrating factor. How do we find our integrating factor? We look at the coefficient we have. The coefficient here, it could be we take it to be the coefficient of x, because it must be the coefficient of x. So, how do we find it? Our integrating factor, which we name as px, will be equal to the exponent, the integral of qx dx. Now, this, the integrating factor, is the one which you are going to multiply with your main function. Then you equate this to the integral of Rx, whatever you have at the end, Rx being multiplied by the integrating factor. This is how we are going to go about our solution. So the first thing we need to do for that first order differential equation, we can write it down. Then after writing it down, let us identify the things we need. We can see our main function is what? It's y. Now, let's ask ourselves, we want to find the integrating factor, which is what? Px. Which is px. Now, let's ask ourselves, what is px? Look, we have to take a letter with this coefficient which precedes y. So if we look at that, if we look at what we have, we can see that it's k, isn't it? So it will be the exponent, the integral of qx, which is what? K in this case, k dx. Now we have to integrate k. When we integrate k with respect to x, we are going to obtain something like this. Now this becomes our integrating factor, and our formula says we multiply the integrating factor with y. So we are going to have it like this. Then we are going to equate it to the integral of Rx. Now Rx, what is Rx? Rx is the whole lot of this. So alpha sine beta x multiplied by the integrating factor, which is this boy, ekx. Now, from here, we can start solving, since we have put it into a solution form. So now, the first thing I'll do, I'll try to not concentrate on this, and dwell much on this part, because at the end, after I have found everything for this, I can come and equate it back to this. So let me write the integral of, I'll take the constant out, sine bx multiplied by exponent kx. Now, you can ask yourself a question. How can you integrate two functions which are multiplying? how can we integrate two functions which are multiplying? We have to remember that we used to use by parts. Now by parts goes with a rule, which is L I A T E. You have to identify where these two functions fall between these respective letters, and the function which is going to start appearing between these, that is what the one we are going to allocate as our u. The later one will be our dv. Now let's ask ourselves, sin x falls into which family? Between the logarithmic family, inverse functions, algebraic, trig, and exponent. You can find that this is a trigonometric function. Now exponent kx, it falls in the exponent family, but now between t and e, which one appears first? It's t. So we are going to use our u will be sine beta, then our dv will be ekx. Now we need to be really acquaintance with the formula for by parts. By parts states that u dv is equivalent to v multiplied by u subtract the integral of v du. Now we are just going to follow this formula with whatever we have here. Now how can we find this du? We just have to differentiate this boy. So du is the same as, when we differentiate sine beta x, it is beta cos beta x. When we integrate dv to find v, we're going to have exponent kx, then we divide through the, when we differentiate the power. Now from here, let's just plug what we have in the formula. What is our v? Our v is exponent kx over k. We multiply it with u. What is u? U is sine beta x. Then we'll subtract v. V, it is exponent kx over k. Then du, it is beta cos beta x. Now from here, we can try to compare with what we have. We can see that our solution will have k sine beta x. We can already see a beta x. Then minus, it's not supposed to be integral, but it has to be minus cos beta x. So this shows us that we will need to integrate this once more. We need to integrate this once more. So already we have this function. We'll write it the way it is. I'll say sine beta x ekx is equivalent to ekx k sine beta x minus, I'll factor out the constants, which is b over k. Then I'll write what I have. Now if you look at this, it has taken us to a scenario which is like this. Now which one will be our u? Already we know that this is a trigonometric function, so it will be our u. This will be our dv. So again we do the process. If our u is equals to cos beta x, our dv is equals to exponent kx. So our v is equals to exponent kx over k. Then our du is equals to beta sine, but now it will be negative, because when you differentiate cos, it gives negative sine. Sine beta x. Now, for you not to get confused, you have to write everything the way they are. Just write it the way they are. So we'll start our answer from here. I'll say this is equal to exponent kx over k sine sine beta x, then I'll say minus bk, then I'll say open bracket. Now we have to follow our formula because we are integrating. Remember, we're just integrating this set. That's why I've said this multiplied whatever will come through. So we are following our formula, which is vu. So I'm saying v multiplied by u, so it is ekx over k multiplied by cos beta x. Then we subtract, which is minus the integral of, now what is v? V is this boy, which is exponent kx over k, then du, which is this boy, negative. So this is multiplication b sine beta x. Now from here we just need to simplify. You can see that we have a sine beta x minus cos beta x, which is showing on our solution. We need to equate that to this.